Alright, in this video segment or series, we are going to learn about geology through the use of diagrams. And the first thing we want to look at or talk about is the layers of Earth's interior. So we're going to do a diagram that shows the layers of the interior all the way up to the crust that we, of course, live on. Now we're going to exclude the atmosphere and talk about everything from the surface to the center. So to start with, we need to draw a round Earth because the Earth is a sphere, an oblate spheroid to be exact, a little bit bulgy at the center, but we're just going to use a complete circle. So we're going to start with a circle. Right. So that's our Earth that we're going to start with. Next, we need to go ahead and trace out some circles to distinguish the interior of what we're going to be talking about. Now, the Earth has three major compositional sections. Those are the crust, the mantle, and the core. So our first circle we're going to draw is going to be everything that's at the surface. Now we're going to make some changes to these layers as we go and talk about the more specific parts of them. Okay, but if we were looking at just the compositional layers, could be the crust, the very outermost section. Now if we were to scale the entire Earth down to the size of an apple, the crust would be as thick as the skin on top of the apple. The crust is relatively small, so our diagram is not going to be perfect. It's not going to be in scale. All right, so the next section is the mantle. So right under the crust is the mantle, and below that is the core. So down in the center we have the core of the Earth. Okay, if we continue the apple analogy, that would be like where the seeds are. Okay, and then the core is divided into two segments, two separate sections, called the outer core and the inner core. So we're going to put a couple circles here, inner and outer core. There we go. So we have the inner core, outer core, the mantle, and the crust. Now, we're actually going to further divide these into multiple sections that we'll talk about. Now, the inner and outer core are going to stay the same, but the mantle actually has three parts, a lower, middle, and upper, and those have specific names. The lower level, or the lower layer, is the mesosphere. The middle layer is the asthenosphere, and then there's a very upper section that actually is included with the outer layers of the crust that we call the lithosphere. So the lithosphere is the crust and the uppermost mantle. Then we have the asthenosphere and the mesosphere. So we're going to designate those layers with colors as we put some paint on this and make the different colors. Okay? So let's go ahead and do the painting for the inner core and outer core and the mantle first. So if you're wanting to follow along in your workbook or your own diagrams, we're going to use yellow for the inner and outer core. Of course, you don't have to use paint. You can use colored pencils or markers, whatever you'd like to use in your sketches, in your diagrams. So we're going to start with this yellow color for the core. Alright, so the inner core and outer core are going to go together. Now the inner core and outer core are extremely hot. The outer core is actually as hot as the surface of the sun, 6,000 degrees Celsius. That's the temperature of the inner and outer cores. Now, the inner core is solid. It is a solid nickel and iron composite, but the outer core is liquid, and we're going to get to talking a little bit more about that in a moment. Okay, now I'm gonna kind of blend the yellow out into the mantle here because that temperature of the outer core, that liquid outer core, keeps the inside of the mantle hot, but as we go up through the layers, the earth is going to get a little bit cooler. Okay, so I'm just going to add in a little bit of yellow about halfway through the mantle. Now the mantle, unlike the outer core, is not liquid, but it's not solid either. It's a combination somewhere in between of both of those. It's kind of like silly putty in that it's not quite a solid and not quite a liquid. As time goes on, that heat from the outer core is going to cause the mantle to shift and flow, and we'll talk about those currents and that phenomenon here in a little bit. But the mantle is actually what we call plastic. Now that's not plastic like you'd think plastic bags or Tupperware or whatever is made of. We're talking about plastic as in a state of matter. It's sort of viscous in that it can flow and it can shift around and move, but this happens over millions of years, a very slow process. Okay, so we're going to come and put red for the outermost mantle, and then we're going to blend the mantle all together, so it should get a nice blend of yellow to red here. Now, as we get closer to the surface of the Earth, it actually gets a little bit cooler. So the hottest part of the Earth is the center. And as we get up towards the crust, it cools down. This is a phenomenon that deep mines have to deal with. So there's some mines down in Mexico and Chile that go really far down into the crust. Nowhere close to the mantle, though. We haven't been quite that far down. But they go really far down into the Earth's crust, and it gets hot. It gets hotter the further down into the crust, into the Earth you go. So the mantle is also pretty warm compared to what we experience on the surface, on the crust. And it's that temperature gradient from the center to the outer crust that actually helps all of these processes that we're going to talk about here in a little while in this diagram. Okay, so the mantle, again, is that semi-plastic, almost a solid but not quite layer, and its temperature gets cooler as you get closer to the surface. So we're just going to blend together that yellow and the red to show this temperature change. It's okay if we don't color inside the lines. There's not a perfect distinction between these layers in the real Earth. Some places they're thicker, some places they're thinner. So it's okay if it's not exact. This is just a very basic diagram to help us understand these concepts. Okay? Alright, so we've got our blended mantle, our outer core, and our inner core. I'm going to clean these lines up just a little bit. And we got it. Alright, now, the reason, let's just go for right now and talk about that white layer on the top as if it is the crust, the uppermost section. Okay? We're actually going to divide it into more sections later, but for right now, let's just imagine that that is the crust. That uppermost layer includes the continents, the oceans, the ocean floors, all the parts that are the crust. And then the red-orange layer that we just finished is the mantle, and then we have the outer and inner cores. Now this structure, we know why it is the way it is. We know why or how the mantle is plastic. It flows, it moves. because of plate tectonics, or rather, plate tectonics occurs because of that phenomenon. Okay, and we know that the outer core and inner core are made of what they are because scientists study the way that earthquake waves pass through them. Okay, so the outer core, mentioned earlier, is liquid. And the reason we know it is liquid is by studying those seismic waves. And seismic waves occur anytime there is an earthquake. And the strongest earthquakes, they can't be felt by people all the way around the world, but seismometers, little devices that measure earthquake waves, can pick up earthquake waves that go all the way through the center of the earth, all the way to the other side. I'm going to finish cleaning this up here. And it's the way that those seismic waves appear on the other side of the earth and how they're picked up that tells geologists what the center of the earth is made of. Okay, and we know that because of those earthquake waves. So let's real quickly use this diagram to talk about how that is studied. Okay, so let's imagine that there's an earthquake at the top here. The earthquake happens, rocks are shifted, and seismic waves radiate outward. Now there's three types of seismic waves. We have surface waves, which are the ones that usually cause the most damage, and they don't go very far from the source of the earthquake. But then we have body waves, which are split into two different types, the primary and secondary wave. Now, the primary wave travels through anything. It can go through both liquids and solids, and it can go all the way through the center of the earth to the other side. So if an earthquake were to happen here at the top, primary waves would radiate outward from that earthquake and move through all of these layers. Now, an interesting thing happens with waves when they enter substances of different density. Okay, so it travels quickly through the crust, but then slows down in the mantle because the mantle's not quite fully solid. It's a little bit more viscous, and it's really dense. So it slows down a little bit, and that changes the way that the waves travel through it. But then it hits the outer core, which is liquid. And when a wave hits something of different density, it shifts. It slows down or speeds up, and it changes its direction. The same phenomenon happens when light enters a prism, and it is split out into its different wavelengths. Okay, so seismic waves travel through the mantle and then hit the outer core, and they shift their direction. But then they hit the inner core, which is incredibly dense. It's very, very dense, and it's very, very solid, changing their direction again. So they're shifted in their direction, and then we have the P waves exiting out of the inner core into the outer core and then down through the mantle again to be detected on the other side with seismometers. Okay, so that's how primary waves travel. Secondary waves, though, those are the ones that really give us some good information about what the inside of the Earth is. Because secondary waves travel a little bit slower than primary waves, and they can't move through liquid. Okay, so when there's an earthquake that happens, they also start to radiate out, but as soon as they hit the outer core, they stop because they cannot go through liquid. So they're deflected around the outer core, and we wind up with this section at the bottom that we call a shadow zone. And it's based on the size and shape of that shadow zone that we can tell what the outer core is made of, and we can tell that it's liquid because of that. We know that the inner core is solid because of the way that the primary waves are deflected, and we know that the outer core is liquid because of the way secondary waves are blocked. Okay, so it's the interaction between primary and secondary waves that result in this diagram that we're talking about right now. The crust, the mantle, and the core. Okay. In the next segment, in the next episode, I guess, we will talk about the layers as mechanical layers. We're going to add a few things. So watch the next episode to figure out what else the Earth, layers are divided into, and we'll talk specifically about the crustal interactions and get more into the plate tectonics side of these diagrams.